All right, I'm going to do my best here to kind of explain some of the lesson from today or yesterday, depending on when you watch this. Lesson six, I had some questions come in, so I'm just going to kind of go through a few of these and work them out, and I hope that they answer some questions or clear up some confusion that you may have. Basically, what this lesson was to get us to look at different situations and answer questions based on the situations with numbers that they gave us, and then eventually take those and convert it to a equation that you could use for any amount of whatever the situation is that they're talking about. Come up with an algebraic equation that could be used for any number. So the warm up here, you just had to replace x with 6. So this first one would have been 6 plus 4, and that equals 10. This would be 7 minus, if we replace 6 with x, would be, so 7 minus 6 would be 1. The exponent of a 2 means that you are multiplying this number by itself that many times. So if x is 6, then that means that 6 that means that would be 6 squared, which equals, oh my gosh, it's supposed to be a 2. 6 squared equals 6 times 6, which would be 36. And this last one, 1/3 x, so that's asking what is a third of 6, and we would put the 6 over a 1, multiply your fractions across, gives you 6 over 3, which means 6 divided by 3, and that equals 2. Lemonade sales and heights. Lynn set up a lemonade stand. She sells lemonade for 50 cents a cup. Complete the table to show how much money she would collect if she sold each number of cups. So we have to think what we would have to do. 50 cents per cup, and figuring out the total money she would make if she sold this many cups. So you have to identify that you would multiply the amount of cups she sold by the amounts that she is selling each cup for. So to figure out the total amount of money that she would get from selling 12 cups, you would have to do 12 times 50 cents. So I could set it up like that and go through. Those will both be 0. 0 times 2, 0. 0 times 1, 0. Add a 0 down here, move on to your 5. 5 times 2, 10. Carry your 1. 5 times 1 is 5, plus 1 is 6. Add those up. That's a plus sign right there. You get 600. But then you have to go back and look. You have 1, 2 spots that came after the decimal in your problem, so you have to go 2 spots over in your answer, place your decimal. She would make $6 for 12 cups. Okay, you would then do that same thing, but with 183 up here instead of the 12. Go through all the multiplication, place your decimal, that's your amount. Now, when you get to C here, that's just saying that we're going to write an equation, or we're going to say how much she would have if she sold this unknown amount of cups. So we don't know what the amount of cups is that she sold. It's just saying that C is the amount, meaning it's an unknown amount. So we're not going to be able to give an exact answer of money collected because we don't know what that C amount is. So the answer for that is just going to be the equation that you would use if you replaced C with a certain number of cups, like we did here in 12 and 183. So your answer there is just going to be the amount per cup, 50 cents. And then we're just going to put a C next to it because that means times C. So the amount would be 50 cents C, and then that's your answer. And you could use that then to replace C with any number of cups. And that is going to give you the total amount of money she collected. So if it tells us that she collected this amount, I'm going to take that equation. I know that she sells it for 50 cents per cup. So 50 cents times the amount of cups that she's selling, and she made $127.50. And so to find out what C equals, that amount of cups that she sold, I need to get C alone. So I need to divide by my coefficient here, which is at 50 cents. Which means I'm going to divide this side by the 50 cents. Okay, so if I were to write that the way it is, it would look like this. 127.50 divided by 50 cents. Okay, now having this decimal here in your divisor is a problem. We want to get rid of that. So I'm going to write an equivalent equation by moving the decimal to the right twice. And if I move it to the right twice in my divisor, then that means I would move it to the right twice in my dividend. So that would have to get moved over. So then I would set it up as 50 divided by 12,750, because that is an equivalent equation. So that answer will match what that answer would be. 50 doesn't go into 1, 50 doesn't go into 12, so I'm going to ask how many times does 50 go into 127? Goes in there twice. 2 times 50 is 100. Subtract 27, bring down your 5. So then I'm asking myself how many times 50 go into 275, which would be 5 times. 5 times 50 is 250. Subtract 275 minus 250 is 25. Bring down my 0. 50 goes into 250 5 times. 5 times 50, 250. Sorry, this is getting written sideways. This must be the way I have this tablet set up. And so when I do that subtraction, I get 0, no more numbers to bring down. So I know I'm done with my division. So my answer is 255 cups. Now if we move on to this problem, Elena's 59 inches tall. Some other people are taller than Elena. Complete the table to show the height of each person. So we know Elena is 59 inches tall, and Andre, Lynn, and Noah are all taller than Elena. We know how much taller Andre is. We know how much taller Lynn is. We don't know how much taller Noah is. So we're just going to use that in replacement of the numbers that we use for Andre and Lynn when we go to answer that box there. So if we know that Elena is 59 inches and we know Andre is 4 inches taller than her, okay, then we know we have to add 4 onto 59. 59 plus 4 is 63. 6.5, I'm going to do that same thing. 59 plus 6.5. 59 plus 6 would be 65, and then add your 1/2, 65 and a half. Now Noah is D, okay, so I'm just gonna, what I would do if I knew what Noah's height was or how much taller he was, I would just add it, but we don't know, so I'm gonna replace 59, or I'm sorry, I'm gonna replace this number here with D because we don't know that height, and that is actually then going to be our answer for that box. Noah would be 59 inches plus D, whatever that difference is. I think that's why they use the letter D for difference. That would be his height. So that might look kind of confusing because you're like, well, that can't be a height. 59 plus D, that doesn't make sense. You can't go to the doctor and say I'm 59 plus D inches tall. That doesn't make sense. And you're right. We don't know the difference. And so what this wanted us just to see is, okay, so to figure out the total height of someone who is taller than Elena, and we know how many inches taller they are than Elena, we could use this equation, and then that's your variable, the number that changes, because that changed for Andre and Lynn because they're both different heights. So that's the equation you could use to find how much taller anyone is than Elena if they are taller. Replace that D with the difference. It says if Noah is 64 3/4 inches tall, how much taller is he than Elena? So then we have to find that difference. Okay, so I could use that equation, 59, I hate that button, 59 plus the difference is going to equal the total height of Noah, which is 64 3/4. Okay, so now I want to get that difference alone. So I'm going to have to subtract 59 from both sides. So I can think of that 64 minus 59. I can set that up. Oh my gosh, that dang button is going to be the death of me. I could do that part first and then worry about the fraction after I do that. So borrow from that, becomes a 5, carry your 1, 14 minus 9. So 5, and then if I took 3/4 away from 5, I still have to do that. I would be left with 4 and 1/4. Because I could view this 5, I could view that as like 4 and 4/4. That is the same thing. 5 is the same thing as 4 and 4/4. So if I take 3/4 away from that, that's where I'm left with my 4 and 1/4. So the difference, how much taller is he than Elena? He is 4 and 1/4 inches taller. All right, let's take a look at the next section here, building expressions. Claire is 5 years older than her cousin. How old would Claire be if her cousin is 10? So Claire is 5 years older than her cousin. How much older would Claire be than her cousin if her cousin is, or how old would Claire be if her cousin is 10? Well, if her cousin is 10 and Claire is 5 years older, then we would have to add 5 years onto her cousin's age. So if her cousin was 10, Claire would be 15. If her cousin is 2, then I'm just going to do the same thing, but instead of 10, I'm going to use a 2 plus 5 years, because she's still 5 years older. Claire would be 7 if her cousin was 2. So these are all constantly changing. That, I think that's what might have made it a little confusing, because it's like, well, here her cousin is 10, but then her cousin's only 2. These are all hypothetical, saying if her cousin was 10 or if her cousin was 2. It's putting you in a bunch of different situations. And so now we've built an equation here, right? Take the cousin's age plus 5, that'll give you Claire's age. So if her cousin is X years old, we don't know how many years old she is. We're going to replace what we did here, her cousin's age, with that X. Okay, but we're still going to add 5 years because it doesn't matter how old her cousin is, Claire will be 5 years older than her. So no matter what that number is, you're always going to add 5 years to that. And that's going to give you Claire's age. But we don't know what that is because we don't know what that X is. So that is actually our answer for that last one. Claire would be X plus 5 years old. Claire is 12 years old. How old is Claire's cousin? Now we would have to kind of think of this in the opposite. Because we know Claire is 5 years older than her cousin, if we know Claire is 12, so I could set up my equation, X plus 5, X being her cousin's age, plus 5 is going to equal 12 in this case, because we know Claire is 12 years old. So her cousin's age, which is unknown, plus the 5-year difference should equal 12, Claire's age. So I want to get this X alone. So I have to subtract 5 from this side. Whatever I do to this side, I have to do to this side. And X, which is her cousin's age, is going to equal 12 minus 5, 7. So if Claire is 12, her cousin is 7 years old. Let's take a look here at this Diego problem. Diego has 3 times as many comic books as Han does. Diego has 3 times as many books as Han does. So if I go even just to like write something here before I even look at the questions that follow, Diego's amount, stupid button. Diego's amount is going to be 3 times the amount that Han has, 3 times Han's amount. And so how many comic books does Diego have if Han has 6? So if I go to this equation I just wrote, Diego's amount equals 3 times Han's amount, I can replace my H with Han's amount, which would be 6. So Diego would have 3 times 6, which is 18. So Diego's amount would be 18 if Han had 6. Now it replaces 6 with N. Okay, so where we have H, we can write that as Diego's amount will be 3 times N books. So we can write it as 3N. And that's then how many comic books Diego would have, is 3N. Again, sounds funny, sounds goofy because it's not a number, but we can't know the amount if they're just giving us N number of books that Han has. So we can say that 3N is the amount because that shows that is 3 times whatever that amount would be. I hope that makes sense. I know I can see how this was confusing. Diego has 27 comic books. How many comic books does Han have? So I could, again, use this equation and replace D with Diego's amount because they tell us Diego has 27. 27 equals 3 times Han's amount, which we are looking for. So that's why I wrote 3h. That's 3 times Han. So I have to think, what do I have to do to get h by itself? I have to undo this 3 times h. So I have to divide it by 3. When I divide that by 3, I'm left with, I wish I could write down here, but I can't. I'm left with h on the left side. And 27 over 3 is the same thing as 27 divided by 3, which is 9. So Han would have 9 if Diego had 27. Again, these situations, they're constantly changing on us the different amounts, which I think contributed to some of the confusion. 2/5 of the vegetables in Priya's garden are tomatoes. How many tomatoes are there? Priya's garden has 20. So if I write my equation before I even get to that 20, I'm going to write 2/5 as a fraction. Two-fifths of the vegetables in Priya's garden. So 2/5, I'm going to say V for vegetables in Priya's garden are tomatoes. So 2/5 times the amount of total vegetables will give us the amount of tomatoes that are in her garden. So how many tomatoes are there if Priya's garden has 20 vegetables? So I would replace this V with 20 because they're giving us a number, and that will tell us the amount of tomatoes she has. So I have 2/5 of means times 20. I'm going to write over 1 to make it a fraction. That's going to give us the amount of tomatoes she has. So I need to multiply across. 2 times 20 is 40. 5 times 1 is 5. 40/5 is equal to 40 divided by 5, which is 8. So if Priya has 20 vegetables, how many would be tomatoes? She would have 8 tomatoes. Now it says X vegetables. So now if I use that equation, that 2/5, and we don't know the amount of vegetables she has, so I'm just going to write 2/5 times X, the amount of vegetables she would have. We don't know what that number is. That's going to equal how many tomatoes she has. So that's my answer for that question is 2/5 X. We can't actually go ahead and solve it because we don't know what X equals. So we just represent then the answer as the equation that would basically saying what we would do if we knew what X was. Priya's garden has 6 tomatoes. How many total vegetables are there? So I'm going to go back to this equation. 2/5 of my vegetables equals, now they're telling us the amount of tomatoes is 6. So I want to get this V alone because the V represents the number of vegetables I have. So I have to divide it by 2/5, which means I have to do 6 divided by 2/5. Okay, so I'm going to actually do that over here so I have a little bit more room. 6, put my 6 over 1, divided by 2/5. I see a division of fractions problem, so that tells me I have to do keep, change, flip. So I got to keep that first fraction the same, change my operation sign to times, flip the second fraction. I'm going to go ahead then and multiply across. 6 times 5 is, whoops, I don't like that they don't have an eraser on here. 6 times 5 is not 60. It is 30. 1 times 2 is 2. 30 over 2 means 30 divided by 2, which is 15. So that is my answer to this problem. There are 15 total vegetables in the garden if Priya has 6 tomatoes. Yeah, you get what I'm trying to do. All right, this one, school paid $31.25 for each calculator. If the school bought X calculators, how much did they pay? So we don't know the amount of calculators that they bought, but if we did, we would multiply that amount of calculators by the cost of each one. So our answer to that is just going to be the equation that we would do to find the answer if we know what X equals. So $31.25 is how much each calculator costs. And we would multiply that by X, and that would give us the total amount once we know what X equals. So then in this next problem, I can take that exact equation and replace the word total with how much they spent on calculators. They spent 500, and we want to know how many calculators they bought. So 31, 25x equals $500. So this X represents how many calculators they bought. Right now it's being multiplied by the cost per calculator. So I'm going to divide that by 31.25, which means I'm doing 500 divided by 31.25. Now this would be one that I would let you use a calculator on because there's no way that we're setting that up as long division. That would be way too much. So 30 or 500 divided by 31.25, 16. So the school bought 16 calculators. Yeah, you know what I'm trying to do. These lesson summaries are really good because it kind of shows you basically what that lesson summarizes that entire lesson into one. So here's another situation about an age. Let A represent your age at any time. Your neighbor's age can be represented as A plus 3. So that tells you your neighbor is 3 years older than you. And that's what it says right here. Suppose you share a birthday with your neighbor, but she was born 3 years earlier than you, so she's 3 years older than you. When you were 1, she was 4. When you were 9, she was 12, because she's 3 years older. When you're 42, she'll be 45. So that's what they showed here. When you were 1, they were 4. When you were 9, they were 12. When you're 42, they'll be 45. So A can be your age at any time. So let's say you're 12. Your neighbor's age would be 12 plus 3, 15. So then that shows that no matter what number you use here, if you add 3, that'll give you your neighbor's age. Okay, these variables represent the numbers that are changing. Okay, and so that's what makes it possible to write an expression that represents a calculation, even though we don't know all the numbers in that calculation. So if we don't know what your age is, we can still represent your neighbor's age by replacing that age with the variable, the number that's going to be changing, to show what your neighbor's age would be. That was a lot. I know this can be really confusing our first time going through it, especially with me not being there in person. Hopefully, this helped cleared it up a little bit. If you have questions, please let me know. Otherwise, thanks for reaching out to me, those of you that did, to let me know that you were confused. Hope this helps. Stick with it. It will get easier. The more we are exposed to it, the more we practice, the easier it will become. Um, Let me know if you have questions.